Lesson 1.3, Part 2, Factor Polynomials. So when you factor, you first want to look for any greatest common factors. Pull that out front. Next, you want to see if there's any difference of squares or perfect square trinomials. Third, you want to do trial and error. And fourth, factor by grouping. Factor completely. Always factor completely. So the first thing you want to do is look for that common term. So if I have 3x squared minus 6x, I can first take out a 3x. And then what am I left with? So it's really like thinking about dividing each of these terms by 3x. So if I take a 3x out of 3x squared, I'm just left with x. And then a 3x out of 6, I'm left with 2. X minus 2. Okay, next one, we can't factor that one anymore. So next one, if we want to factor that, so let's see what goes into all of them. So we have an 8, a 6, and a 2. So first of all, for all the numbers, we could take a 2 out. And then for the variables, you want to pick the variable that's in all three of them that has the smallest power. So I have x to the 4th, x to the 3rd, x to the 1st. So we can only take out an x. Has to be in all three of them. X squared, x to the 3rd, x to the 4th. So think of, or y. Y squared, y to the 3rd, y to the 4th. Think about how much y can you take out front. Smallest one was y squared. And now what are we left with? Okay, so if I take out that 2xy squared out of each of these, what am I left with? So in the first one, 8 divided by 2 would be 4. X to the 4th over x. We still have 3 of them left. So we took 1 out, but there's still 3 left, and the y's completely cancel. Okay, 6 divided by 2 was 3. X cubed over x would be x squared. Y cubed over y squared would be y. And then 2 divided by 2 would be 1, but we still need to keep this minus in there. We don't have to write 1 unless it's the only thing left. X over x cancels, y to the 4th over y squared. We're left with y squared. Okay? All right. This one is kind of set up with the factoring by grouping method. So you can see there's this x minus 3 in both of these. So instead of pulling out like a 3x, we're actually going to pull out that entire factor, x minus 3. So if I take an x minus 3 out of this one, and an x minus 3 out of this one, what am I left with? So we would be left with 2x plus 4, and then minus 5. So we can finish that up, simplify that, x minus 3 times 2x minus 1. 6x squared plus 7x minus 5. You did these a bunch when you were learning the nitty-gritty of factoring. So the first thing we need to do is kind of figure out how should we break apart 6x squared. So we could do 6x times x, or we could do 3x times 2x. I usually tend to start with the one that's more in the middle, so like the 3 and the 2 instead of the 6 and the 1, but either could work. Both won't work, one or the other will work. So I'm going to try the 3x and the 2x. So that's how we kind of figure out this is our first term, and we would be multiplying those together to get that first term of FOIL. Okay, then the last term is going to be this minus 5. So what two numbers multiply to be 5? We only have one choice, 1 and 5. Okay, so if I try it one way, 1 and 5, see if that works. So when I say see if that works, we want our inside and outside value to be this 7x here. So 15, there we go. Okay, so to get the inside-outside value, you're going to do the inside and the outside and then combine them together. So can 2x and 15x give me 7x, either by adding or subtracting it? No, it would either give me 17x or 13x. So we're going to erase that. This would be something you want to use a pencil for. And switch around. Put 5 here and 1 over here. So now my inside value is 10x. My outside value is 3x. So can I get 7x out of 10x and 3x? Yep, we can. So we need to figure out the signs on these. So 7x, the bigger one needs to be the positive, and the smaller one needs to be the negative. So it's going to be plus over here, minus over here. You can always FOIL it back out like we did for yesterday's lesson and see if it works out. So those are the factors. Okay, difference of squares. So if you see that both of these numbers are a perfect square, that should give you a sign kind of to break it up, that you're going to have 4x squared, 2x and 2x, 25, 5 and 5. And then notice this one, we want our inside and outside term, FOIL, to be nothing. There is nothing there. Okay? So how would I get that to be nothing? Well, we want a positive 10x and a negative 10x. Now together they equal 0. Okay? So that's difference of squares. So use the same ideas, but this one's a little bit different because you don't just have x's and numbers, you have x's, y's, and z's. So think about how we did that. We rewrote that x plus y in both of them. And then we're going to break apart this z. And then to get difference of squares, one of them is going to be plus and one's going to be minus. Okay, for difference of cubes, if we have a cubed minus b cubed, so what we want to do is think of, we're going to kind of use this as our starting spot here. We want to break apart that 27x cubed to be 3x all to the third power, right? Because 3x times 3x times 3x is 27x cubed. And then minus 1 cubed. So this becomes our a here, the 3x, and then our b is just 1. So we can rewrite this. A, 3x, minus 1, and then, so difference of cubes, that's where your subtraction sign is right there. The rest are going to be positive. Sum of cubes is going to be switched around. Okay. So 3x cubed minus 1, we can break that up to be 3x minus 1. And then what we need to do is take that a part and square it. Be careful with this step. It's easy just to write down 3x squared, but that should actually be 9x squared. Okay, so 3x squared and then plus ab. So we need to multiply both of those values. So we're going to take plus 3x and then times 1. Now notice our b is just 1 because there's the minus in the function. And then plus b squared, plus 1 squared. Okay, so just continue rewriting that. 3x minus 1. 3x squared would be 9x squared plus 3x plus 1. So that would be difference of cubes. All right, this one is a perfect square trinomial. You might not recognize it right away, but if you can tell that these are both perfect squares, that might be a good starting point. So 4x squared, break it up 2x and 2x. Y squared, break it up y and y. Notice your inside would be 2xy. Your outside is also 2xy. But I want minus 4 of them. So both of those need to be negative. Okay, so now we can just shortcut this when we write this. If we have a perfect square trinomial, this means that both factors are the same. So we can break it apart to just be 2x minus y all squared. Okay, don't forget, number 9, we want to take out that greatest common factor first. First thing we can do is take out a 2x squared. So see if you can finish that one. And after we take out that 2x squared, we're going to actually factor it further. So go ahead and pause the video. Try to finish that one and number 10. So see if you can do 9 and 10. All right, number 9. After we take out the 2x squared, we're left with x squared minus 4. And then we can break that apart again. X squared, we can break apart x and x. 4, 2, and 2. Difference of squares, 1 plus, 1 minus. Okay, number 10. We can take out the xy squared out of each of them. We're left with x to the 4th minus y to the 4th. From there, we have difference of squares again. So x squared plus y squared, x squared minus y squared. And then we have difference of squares again. So we can leave this beginning part because we don't have sum of squares, it's difference of squares. So then we can break apart x squared minus y squared to be x plus y, x minus y. So that would be the complete factorization. All right, let's try the grouping method. So for the grouping method, what you want to do is put your factors together. So look at like these first two and see what you can pull out front. Then look at the next set and see what you can pull out front. So on those first two, we can pull out an x squared. So if I take out an x squared, what am I left with? Don't forget the 1, so x plus 1. Okay, the second part, 4x plus 4, we can take a 4 out. And what are we left with? X plus 1. Okay, so then it's kind of like that greatest common factor. What can I pull out of each of them? Well, notice both of them have this x plus 1. So we can take this x plus 1 out front and then write what you have left. So if we take an x plus 1 out of this first part, those just cancel. So it's x squared. And then if you take an x plus 1 out of the second part, those are going to cancel. X squared plus 4. Now if it was x squared minus 4, we could keep going. But x squared plus 4, we can't keep going. You'll have imaginary numbers for the other factors. All right, why don't you guys pause the video and try number 12. All right, so by the grouping method, we can look at this first set here and take out an x squared. The second batch, don't forget if there's a minus, take out that negative 3 at the beginning instead of just 3. Otherwise, your two factors wouldn't line up to be the same thing. Okay, so then if I pull out that x minus 2 clear out front, we're left with x squared minus 3. Now, if that 3 was a perfect square, like a 4 or a 16 or something, we could keep going further. But since it's a 3, we're going to have radicals in our factors, so we'll just leave it that way. All right, so your assignment, page 34, 63 to 83 odds, 98 to 110. You're going to do every third problem. So 98, then 101, then 104, then 107, then 110. Okay, so go ahead and complete that and turn it in on Canvas.